Imagine, if you will, that you've just stumbled upon an old, dusty book in the attic of your childhood home. You open it and find it's filled with maps of places you've never heard of, sketches of celestial bodies, and cryptic notes in the margins. You're intrigued, but also a bit perplexed. What is this mysterious book, and why have you never seen it before? That's the feeling astronomers had when they first turned their telescopes towards the Large Magellanic Cloud. It's like this cosmic manuscript that has been sitting in our galactic backyard, waiting for someone to crack it open and decipher its secrets. And oh, what secrets it holds! From star-forming regions that defy our understanding of physics, to a bridge of hydrogen gas that connects it to another galaxy, the Large Magellanic Cloud is a treasure trove of cosmic mysteries. But here's the kicker. You don't need a PhD in astrophysics to appreciate these wonders. You just need a sense of curiosity and a willingness to venture into the unknown. So, are you ready to explore these mind-blowing mysteries with me? By the end of this journey, you'll look up the night sky with a whole new sense of wonder. You know how every superhero has an origin story? Batman had tragedy in Gotham, Spider-Man had a radioactive spider, and Superman had the death of Krypton? Well, galaxies have their origin stories too, and the Large Magellanic Cloud is no exception. But here's where the plot thickens. Its origin story is still being written, like a novel with multiple authors arguing over the first chapter. Imagine being in a family reunion where everyone is trying to piece together your great-grandparents' history. Aunt Sally insists they were farmers, and Uncle Joe is convinced they were adventurers. And Grandma? Well, she thinks they were royalty. That's the scientific community for you when it comes to the Large Magellanic Cloud. Some say it was once a spiral galaxy, elegant and organized. Others argue it's always been a bit of a cosmic rebel, defying categorization. But let's add another layer to this cake. What if I told you that our very own Milky Way might be the villain in this story? That's right. Some theories suggest that the Milky Way's gravitational pull disrupted the Large Magellanic Cloud, turning it into the irregular galaxy we see today. It's like a big plot twist in a blockbuster movie. Except this is real cosmic drama unfolding over countless years. As we delve deeper into this mystery, remember that we're not just talking about stars and gases, we're talking about a cosmic identity crisis. And just like any good mystery, the clues are scattered, the suspects are many, and the truth? Well, the truth is still out there, waiting for someone to put all the pieces together. Have you ever heard the story of the Brooklyn Bridge? Built in the late 19th century, it was a marvel of engineering at the time, connecting two worlds that were, for all intents and purposes, separate entities. Now, what if I told you there's a bridge in space that's doing the same thing, but on a galactic scale? This isn't your run-of-the-mill steel and concrete bridge, obviously. This is a bridge made entirely of hydrogen gas, and it's connecting the Large Magellanic Cloud to its smaller sibling, aptly named the Small Magellanic Cloud. Picture two celestial islands in the vast ocean of space, linked by a bridge that's invisible to the naked eye, but as real as the device you're watching this video on. Digging into the nitty-gritty, this bridge isn't just a simple line of gas. It's a complex structure that's puzzling scientists to no end. Imagine a jazz musician hitting a series of unexpected notes, creating a melody that's both beautiful and perplexing. That's this cosmic bridge. It's not following the rules of cosmic structure, and that's what makes it so interesting. And here's where the twist comes in. What if this bridge is actually a relic of a past interaction between these two galaxies? Like an old love letter found in the attic. It could be a clue to a long-forgotten relationship. Some scientists speculate that these two galaxies were once much closer, perhaps even on a collision course. And this bridge is the only remaining evidence of that cosmic encounter. So as we cross this cosmic bridge together, ponder this. What other secrets is it hiding? Could it be the key to understanding not just these two galaxies, but the very nature of our universe? You know how in towns there's always that one house at the end of the street that kids dare each other to approach on Halloween? The one shrouded in legends, where every creak of the floorboards and every gust of wind fuels the local folklore? Well, in the cosmic neighborhood of the Large Magellanic Cloud, that house is called the Tarantula Nebula. Now, don't let the name alone scare you off. The Tarantula Nebula isn't some cosmic horror show. It's more like the prodigy child of the galaxy. Imagine Mozart composing symphonies at the age of 5, or Picasso sketching masterpieces as a toddler. That's the Tarantula Nebula, but instead of music and art, it's a prodigy at star formation. It's the most active star nursery we know of, a place where stars are born at a rate that leaves scientists scratching their heads. But here's where we take a detour. What if the Tarantula Nebula is not just an anomaly, but a window into the past? Picture this. You're at an art gallery, standing in front of a painting that's unlike anything you've ever seen. You're captivated, but also a bit puzzled. Then, you read the artist's note and realize this painting was their attempt to recreate an art style from centuries ago. Suddenly, the painting takes on a whole new meaning. That's the Tarantula Nebula for you. Some scientists believe it's showing us what the early universe looked like, a kind of cosmic time capsule. It's as if the nebula is saying, hey, want to know what things were like billions of years ago? Take a look. Think of the Tarantula Nebula as that enigmatic painting in the gallery of the Large Magellanic Cloud. It's not just a spectacle, it's a clue, a riddle wrapped in a puzzle of cosmic dust and gas. Have you ever walked into a room and immediately sensed that something's a bit off? Maybe the furniture is arranged in a peculiar way, or there's a painting hanging crooked on the wall. Your brain can't quite put its finger on it, but you know something doesn't fit the norm. Now we're talking about the conundrum that is the barred irregular shape of the Large Magellanic Cloud. Now, in the world of galaxies, there are the classics, your spirals, your ellipticals. They're like the Beatles and Elvis of cosmic shapes. Everyone knows them, everyone loves them. But then there's the indie band that's defying genres and making you question the very definition of music. That's our Large Magellanic Cloud. It's not a spiral, it's not an elliptical, it's a barred irregular. So what exactly is a barred irregular? Imagine a galaxy that started off like any other, perhaps as a spiral or an elliptical, but over time, due to gravitational interactions or other cosmic events, it lost its original form. Now, it's a mishmash of shapes and features, including a central bar made up of stars and other cosmic material. It's like a puzzle that got all jumbled up and then partially reassembled in a new but unexpected way. And here's the kicker. This irregular shape might not be a quirk, but a clue. Think about the Mona Lisa smile or the unexpected ending of an Agatha Christie novel. They make you revisit the entire story, looking for missed details. Similarly, the barred irregular shape of this galaxy could be a clue to its past, its interactions with other galaxies, and maybe even its future. Consider this. What if the very thing that makes the Large Magellanic Cloud so hard to categorize is what makes it essential to understanding the universe? It's not an outlier, it's a case study. You know those moments that define a generation? The moon landing, the fall of the Berlin Wall, or even the launch of the iPhone? These are events that become cultural touchstones, shaping the way we see the world. In the realm of astronomy, one such moment was the observation of supernova 1987A. Now, supernova aren't exactly rare. They're the cosmic equivalent of fireworks, lighting up the night sky in a brilliant display of pyrotechnics. But supernova 1987A was different. It was like the headliner at a music festival, the act everyone had been waiting for but didn't quite know it yet. You see, before this event, we had theories, lots of them, about what happens when a star explodes. But theories are just educated guesses until proven. This supernova was close enough, just about 168,000 light years away in our cosmic backyard, the Large Magellanic Cloud, to give us unprecedented data. For the first time, scientists detected neutrinos from the explosion. Now, neutrinos are elusive particles. They're like the introverts of the particle world, rarely interacting with others. Catching them was like capturing whispers from the universe, whispers that confirm theories about the core collapse of massive stars. And let's not forget the aftermath. The remnants of 1987A have been a playground for researchers, allowing them to study the formation of dust and molecules in the wake of a supernova. It's like the universe gave us a laboratory to understand the elements that make up planets, stars, and maybe even life itself. So when we talk about supernova 1987A, we're not just talking about a bright spot in the sky. We're talking about a cosmic Rosetta Stone, a key to unlocking the language of the universe. You know how every compelling story has that enigmatic element that keeps you guessing? It's like the secret ingredient in a recipe that makes the dish unforgettable. In the cosmic narrative of the Large Magellanic Cloud, that secret ingredient is dark matter. Imagine you're watching a suspenseful movie. There's a mysterious briefcase that everybody's after, but no one knows what's inside. It's the linchpin of the whole plot, yet its contents remain a mystery. That's dark matter for you. Now, in the Large Magellanic Cloud, this mysterious briefcase is unusually prominent. It's as if you're watching a series of films, and that same mysterious briefcase keeps popping up in every sequel, each time playing a crucial role. Scientists have found that this galaxy has an unusually high concentration of dark matter, more than we'd expect for a galaxy of its size. It's like discovering that a small town holds the key to an international mystery. Why should we care? Well, dark matter is the gravitational glue that holds galaxies together. It's the unseen force that shapes their structure and even influences how they interact with each other. In the Large Magellanic Cloud, this abundance of dark matter could be the reason behind its unique features, like its irregular shape and its cosmic bridge to its sibling galaxy. Additionally, the Large Magellanic Cloud is on a collision course with the Milky Way. What happens when a galaxy so rich in this secret ingredient merges with our own? It's like the season finale where the mysterious briefcase is finally open, changing the storyline forever. You know how in life some encounters are just inevitable? Like running into an old friend in a city of millions, or finding that one book you've been searching for in a dusty old bookstore. There's a sense of destiny, a feeling that some things are just meant to be. Well, the Large Magellanic Cloud and our Milky Way are on such a destined path. They're set for future collision. And not just any collision, it's one that could rewrite the cosmic rulebook. This isn't a fender bender at a stoplight. It's more like two colossal ocean liners on a collision course in the open sea. And just like how the impact between two such massive vessels would send ripples across the water, the collision between these two galaxies will send shockwaves through the universe. It's a cosmic event that astronomers are eagerly anticipating, like fans awaiting George R.R. Martin finally releasing The Winds of Winter. Please, George. Let's delve deeper into the mechanics of this cosmic event. When the Large Magellanic Cloud and the Milky Way collide, it's not just a celestial fender bender. It's a complex gravitational tango that will unfold over millions of years. The Large Magellanic Cloud is rich in dark matter, and this dark matter will have a profound effect on the Milky Way's spiral arms. Specifically, the gravitational pull from the dark matter could warp these arms, altering their shape and density. This could lead to new star-forming regions within the Milky Way, essentially rewriting the map of our galaxy. But the implications go beyond merely reshaping parts of the galaxy. This collision could serve as a cosmic laboratory for understanding dark matter itself. As the two galaxies merge, the gravitational interactions between their dark matter could lead to phenomena we've never observed. For instance, we might see fluctuations in the density of dark matter within the Milky Way, which could help us understand its elusive nature. Moreover, the collisions could disrupt the orbits of stars and even black holes within both galaxies, offering us a unique opportunity to study how dark matter influences the dynamics of celestial objects on a grand scale. And with that, we conclude our exploration of the mind-blowing mysteries of the Large Magellanic Cloud. Check out the video on your screen now to continue your journey through the cosmos, and as always, thank you for watching.